Hi everyone, welcome to Data Exploration with Smart Mapping in ArcGIS Online. I'm Jennifer Bell, and I'm a geographer on the Living Atlas team here at Esri in Redlands, California. And I'm here with Jim.
Hey, good morning or afternoon, depending on what time you're listening to this. I'm Jim Harris. I'm a geographer, also on the ArcGIS Living Atlas team in Redlands, California.
So today we're going to talk about why you need smart mapping in your life and how data exploration will help you make better maps and apps. But before we begin, I would like to share some emails I've received from some developers at Esri. So let me know if any of these things sound familiar to you. I have a particular app that's getting close to being ready. However, the Carto just isn't awesome, particularly the colors. I want them to pop and be beautiful. Can you have a look? Or, the data's pretty darn big. After a lot of trial and error with standard symbologies, I'm stuck. I've already spent quite a bit of time trying to figure out alternative solutions, and I really could use some expert help. And lastly, help! I have a few maps that I'm trying to make prettier. Would you be able to make some suggestions? This was due yesterday.
Yesterday, of course.
Exactly. I mean, all of us experience this. This was due yesterday, or this is due today at 5 p.m. We're on a deadline. We don't have a lot of time, but smart mapping helps you make very beautiful maps very quickly. Another common thing we see is, can you change the colors? I want to make it prettier. And that's another common misconception, is that it's about the colors. The colors are going to make your map instantly better. Well, that's not the case. Really, with smart mapping, it's all about, the rendering style that you choose, the data breakpoints. So are the breakpoints matching the spread or the patterns of your data? And, lastly, I really could use some expert help. Well, with smart mapping, you don't have to be an expert, and hopefully you see that today. So what we'll cover is, what makes a great map. We're going to go through some map makeovers before and afters, give some demos, and end with Q&A and resources. So if any of those quotes that I just shared above sound familiar to you, whether you're the one writing the email or receiving that email, this presentation is for you. So Jim, let's talk about what makes a great map.
Yeah, sure. The map is such a big part of the user interface, and it's important that it speak to someone as soon as they see it. They have a reaction to it that's positive. They see what they expect to see, and oftentimes this would be ideal, right? This is the challenge that we wish we had when we're trying to build a mapping application. We would have a clear problem to solve, and we know how to solve it, and we have all the data we need. We have great ideas for the map and a particular audience in mind. Of course, unlimited time is a luxury, and unlimited resources. This would be great. I would make maps under this condition. Would you?
Yeah, definitely. That's ideal.
But the reality is a little bit different. This is more the challenge we usually face. We don't know exactly what problem to solve just yet. We're not sure how we're going to solve it in an app or a map. We have some data, and maybe we're gaining confidence in that data over time, or maybe we're a little skeptical at first. We may have some ideas for a map, but maybe we haven't looked around to see what other people typically do with data like this. So a lot of times we'll end up just throwing the data on the map to start. If you throw data on a map to start, I'm okay with that. If you don't do anything with it after that first attempt, well, then you're probably not going to have the best map. Maybe we don't think about the audience, so we haven't asked a question, who's actually the target audience for this? The general public is a cop-out in most cases. Let's have a specific audience in mind. And of course, none of us actually operate under unlimited time limits and unlimited resources. We all have budget, and we all have expectations of deliverables. So how do we kind of get there? And I would encourage everyone on this who's watching this to think about a great map as a window into information. The map is the app. The map and any application functionality, they just go hand in hand. So for example, this San Francisco Transit Access is showing you the transit lines. You can see those lines. You can see the stops. There's no legend. but I can just say, this is the transit lines and the stops. You look at it and you think, yeah, that's about what I would read. And the pink areas show you areas that are within a 10-minute walk of each of those stops. So immediately you get kind of a sense of where the buildings are, where the structure of transit looks like in San Francisco. And this is ready for insertion into an application. Maybe it tells you about the stops. Maybe it tells you about the on-time performance of the buses that stop there, or how often those stops are served. We are going to let you in on a secret. Right, Jennifer?
Mm-hmm.
We let other people's work inspire our thinking. We look around at maps. We do searches. We look at what other folks are doing to kind of say, oh, that's a good pattern. I wonder if that pattern would work well with this data. So, for example, our partner AccuWeather has a very interesting layer that includes an attribute, has many, many good attributes like, the current temperature, but also has what is the change in temperature expected in the next 24 hours. And when I saw that field, my brain immediately lit up. I thought, oh, I think I've seen a map like this where, we just kind of color each observation point with a color that represents increase in temperature, red, or decrease in temperature, blue. And I bet that when the change in temperature is not that great, it'll act kind of like a buffer in between the areas that are warming up and the areas that are cooling. And I bet it'll look, in my mind's eye, it kind of came out exactly like this. And then using transparency to emphasize those areas of large temperature swings, like on screen, it's a 14-degree change in the next 24 hours at that station. And then, so I made that very bright. And everything that's, if it's like a half-degree change or 1-degree change, not so bright. It's not so important to the purpose of this map. That's an editorial choice, of course. Sometimes the map inspires more coding. I think this is an example from our colleague, Christian Akenis, who built a global temperature anomaly map with all these readings, estimated change in global temperature at all these points, in this case in a Web Mercator projection, and across the years. So this is a very rich data set. It's multiple dimensions. It's got location, it's got temperature, it's got time expressed in years. And so it's just begging to have an application experience where there's a slider bar and you can go across. But notice the subtle use of color. Very similar to the previous one, areas in blue are cool, areas in red are hot, very straightforward. This is an example of how this data comes alive, not as a single map, but as an interactive map. So what do all these great maps consider? You could list probably 50 things. These are the 9 or 10 that we've been talking about lately. Great maps consider, in purple there, the data, the story, and the cartography. Like those are the 3 things you're going to have to deal with to have a successful experience of that information. But also knowing the audience, thinking about the medium. Are you going to do a print map? Are you going to do an online map? Is the online map going to get put on a website where the online map is basically 4 inches wide? That's always a challenge. How do you get meaningful information out of a map that's 4 inches wide? I don't care whether it's in print or on a web page. So we always fight for as big a map as we can get. No big surprise there. But the medium matters. Any analysis that has been done or needs to be done is part of the consideration. It could be the data you're handed is not the best expression of that topic. It could be the raw data you're handed needs some help, needs some love, needs some analysis. People have preferences. I've never met people who love to receive bad news. So it's all about how do we package bad news and how do we package good news in terms of maps to present the information in an honest and straightforward way, but also respect what are any sensitivities about the subject matter that the audience has in mind. I also mentioned here the idea of opportunity. Kind of gets the sense of timing. How much time do I have to work on these maps? And how cooperative are the people I'm working with? And how stretchy is their imagination? Because you could push too hard for something and end up getting nothing. So it's all about the nature of the opportunity. We tend to try to meet people where they're at, give them the exact map they ask for, but also push a little bit. Let's see if we can stretch their thinking on this if that is useful to the mission, if it's useful to the job. It's not about us. It's about what are we doing to support their mission. And the last thing I put is permission. Nobody ever told me for the first 6 months I started doing this particular job. People kept asking for map after map after map, and I finally realized what they were doing was they were giving me permission to try things, and that's a gift we try to share with others as well. So you, by attending this workshop, you now have permission to try additional things in your map making. Now, why bother? I mean, what's the point? Just to make a map look pretty? No, we don't make pretty maps. We try to make useful maps. And the reason why is it's often 80 to 90% of a mapping app's real estate. Like if you just look at the screen, how much of it is consumed by the map? So it needs to be purposeful. It needs to deliver on a promise. If you don't know what that promise is yet, well, as soon as you start, you're going to be that much further down the road. We look for maps. This is a phrase that's used around campus here. Maps that are informative at a glance. So from the back of the room, somebody walking by can kind of look on screen and surmise what is going on. The reason that's important is when it is informative at a glance, a map is building confidence in the reader. They figure, okay, this thing knows what it's doing. And when great maps are consistently delivered, we find it leads to more and more requests from our customer, from our user, from whoever our stakeholder is. When they start to gain confidence in what you're doing, they start to ask for more functionality, more analysis, more interactions, and somebody's got to write that code. So that's why we think great maps lead to great jobs.
That's so true, Jim. We see that all the time in our work. So what makes a great map? Well, let's find out with some map makeovers. We'll show some maps of before and then after, little things that we've done to improve the map. So here's a map that shows a live traffic layer. It uses red, yellow, and green to show the amount of traffic. However, the base map has a lot of red and green in it, which can be misleading. These roads here have this orangish-red color. It could appear that there's a lot of traffic. One simple change you can do with your maps is change the base map. So here's before, and here's after. So the solution is to switch to a less colorful base map. This one is called the navigation base map, and it was created with this kind of use in mind. Here, the layers instantly shine and pop from the map. Next, we have a map that shows this classic problem of dumping dots on the map. When you have so many dots on the map, it hides what we really want to know. In this case, we see complaints. So when the complaint occurred, the status, if it's opened or closed. In this case, it's rubbish in this area. They called it Mount Trashmore, very creative, and the compliance state. So, so that's when it was solved or addressed. Now, this is fine, but if we actually use the attributes or the information in behind the layers to determine the symbology, we get a better story. So here we're emphasizing what people actually care about. If I lived in this area, I would care about complaints that are past due. Here in red, these complaints have been open for over 90 days, so that's really important. The bigger the diamond, the more recent the complaint or compliance date was. Here's another map. In the before image, we have a base map and a layer that are also competing with their colors. And this layer is using a classification style called Jenks classification. And right now it's hiding anything that's interesting. So after we make some changes, here's that familiar map that Jim was talking about earlier. This map focuses everything on the particular subject of change in temperature. Red is hotter and blue is cooler. Notice it's using a neutral dark base map. We have neutral dark and neutral light base maps that you can choose from. That really lets the layers shine. The bigger the change, the brighter the color. It's also using the rotation based on the increase or decrease in temperature. So here it's not using any classification style. It's continuous, so it's letting the data breathe. And you're going to see this term a lot, letting the data breathe, in this presentation. And lastly, we have this map that shows native species richness. It's using, a classification style that has 5 breaks. And in this case, any value of 1,301 all the way to 1,899 is shown in the same orange color. Then all of a sudden, at 1900, you get a red. So if the science or the policy makes it that the classifications are warranted, for example, earthquakes and magnitude, those have certain breaks. Or if the policy says, you must meet 50% compliance or you're out. So those would warrant classifications, but most of the time, the classification hides the data's variation. So if we use a continuous style, here we see high to low theme. 1900 does show red, but there is an increase in detail that was hidden before. So here's before and here's after. All right, so now let's do some live before and after maps. We'll dive into the demos, starting with Jim's demo on COVID-19.
All right, thanks, Jen. I think this is going to be interesting. Is my mouse working? Yeah, there it is. Great. This is obviously in the news. We're recording this on March 18th, so have that in mind as far as context goes. We're working with the Johns Hopkins layer in the map. It's available in the Living Atlas, and I'm going to show just some of the map-making realities of this data set. So we've seen this map by now many, many, many times, and I just wanted to show you kind of the thinking that may go into this style of mapping, right? So one of the things that everyone mapping this subject right away recognized is Hubei province has the majority of cases, even from the start and even today, nobody is close to 68,000 cases on the map. Now, let's start from the layer itself. We have a layer called all cases. And if we jump in here and say, I want to map all the confirmed cases. So we touch smart mapping. We tell it what attribute we're interested in. There are all these attributes. Very easy for you to just quickly explore different things. I could choose to map deaths, and it's going to react right away. I could choose to map recovered, and it's going to react right away, and I can start to go from there. We always encourage you to look at what the software suggests. And remember, it's a suggestion. It's just software. We call it smart mapping because it's going to work with the base map you have on screen to help decide what color palettes might make sense. We call it smart mapping because it's going to look at the attribute you touch and recommend different maps based on that. But as always, as with any piece of software, the most it can do is suggest some settings. So I want you to watch what happens to this map, especially globally. If I back out one, watch what happens globally as we try different sizes for that max, or different values for which feature should get this maximum 50-point size. So what this is saying is at 42,000 cases, if you have 42,000 cases in your country, we'll give you a 50-point symbol. And if you have one case, we'll give you a minimum size of 8. So maybe one case, I might take that down. You can kind of see the map changing instantly, right? And maybe one case deserves a point that size, arguably. I don't know. Let's leave it there for a second. The cost to experiment with smart mapping is so small that you don't feel like you're wasting your time by exploring the data. I think that's one of the main things Jennifer and I and others value in working with this platform. But I want you to notice, we're dealing with data that's got a pretty significant outlier, right? That Hubei province is the only one with 67,000, and most features have far fewer. And the nature of that is particular to this data set. Some of these features are a province. Some of these features, like South Korea, it's a whole country. Some of these features are a state in the United States, and so forth. So there's at least 3 levels of geography kind of being represented in this data set. So if I play around with this, the worst case scenario is only one feature is going to get a big symbol. The largest symbol we can afford is 120 points. That's the largest the platform allows on this particular style of map. So I could do this, but watch what kind of happens. I mean, as the number of cases starts to grow in other countries, here's the United Kingdom. They have 2,600 cases, which is a pretty good sized number, but it's very hard to get any, real estate, screen real estate on here. And the only way you're going to get that is to, as I say, increase the maximum size and then start to say, well, I'll give you the maximum size if you get, I think the next biggest country is at about, I think it's Italy at about 30,000 cases currently. Yeah, about 32,000 cases. So now Italy looks almost as big as Hubei. So these are judgment calls. What we've been kind of doing on this map, frankly, is making Italy to be about, or whoever is the next largest feature in terms of cases, make it be about 2/3 the size visually of Hubei province, since until someone surpasses, God help us, I hope nobody does, Hubei province's count, it's going to dominate this map. So this is the flexibility you have, and I just wanted to share how the map seems to respond to different settings. You can also drag this up. So now you're saying nobody gets anything bigger than a 4-point symbol unless they get to 35,000 cases. I mean, that's just ridiculous, right? You can see that on the map. So these kind of interactions lead us to make a map like this, where I chose to put Hubei province in its own layer. Like, it's such, especially 2 weeks ago, it's such an outlier. And, the maximum value there is just what it is. And then put the other cases on a scale where, every day I check what's going on in Italy and kind of jump in here and say, okay, well, the largest size, I'm using an 80-point symbol compared to the 120 for Hubei. And right now, the maximum size is 35,000, and we'll come in here and we'll update this to say, okay, maybe we'll go to 36,000, drag this up. And that way, Italy continues to represent the next largest number of cases. I think the way this looks here, I would also jump in and just say, let's put a little more transparency on the symbol itself. And then maybe we would do a little bit more with the outline. Yeah, so now you can kind of see that Italy is not covering up all these other countries. And a lot of times people want to see this first map, but another factor in making this a useful map is kind of deciding at what point should we start to add value, like a label. As you zoom in, we'll get the actual count for the different locations. And then someone pointed out to me, at a certain scale, you want to turn this off because you don't want to imply that there are 275 cases in Slovenia and they're right here at this particular location. That's not exactly what we want to communicate. So we chose to turn off the layer at this scale. That's a subjective decision. So that's just kind of a quick tour through how we dealt with cases, and then debts is dealt with in a similar way. Right now, we're kind of mapping it this way, where the maximum number gets the biggest size at 2,800 cases. And like I said, we'll come in every day and make these adjustments. So that's what I wanted to show with this particular case, taking kind of from the headline news, a data set of interest.
Wow, that's really important work. So thanks for sharing that, Jim. Let's move on to the next demo. Here we have the transportation to work variables that's found in the American Community Survey layers in the Living Atlas. Jim showed his demo in the current map viewer, which is using the 3x JavaScript API, and I'll share this one in the map viewer beta. Now, the first thing I always do when I add a layer to a map is change the base map. And one of my favorite ones is the Human Geography Dark base map, but we also have Human Geography Light. Newspaper is a good one, Modern Antique, Nova, World Imagery Firefly, or you can make your own. So this is a multi-scale layer. So it starts off at the state level. Then as you zoom in, we see counties and tracks. So to go to Smart Mapping, you open up the Styles panel, And we see the current field that's being mapped, the percent of workers who commuted by driving alone to work. And this is using the counts and amounts color rendering or drawing style. And we see the histogram of the data, the average of the data set here, it's 80%. And we can change the color ramp and use these categories to help you pick a ramp that's best for your data set. There's a category called Best for Dark Backgrounds. This is a nice category, especially for this base map, because these colors really, pop and shine on your map. What I like to do is remove the outline of the boundaries, of the county boundaries, just to let the data breathe a little bit. And another thing our team recommends is changing the theme. So right now it's using high to low, but I recommend using above and below. It makes your map a little more meaningful. Here the ramp is centered around an average value, and we could change this to any value, whether it's a policy or a goal that the location is trying to meet, or maybe they're not meeting. And usually reds have a negative connotation. So to me, if over 90–95% of the workers in a county commute by driving alone, that's not ideal. So I'm going to reverse the color ramp so that red is on top. And we can zoom in to see the histogram a little bit better. I like to round the values so that they look very nice and they're easy to read on the legend. But what's nice about this is the software gives you a suggestion. It says, well, here's the average, and then here's one standard deviation above and below the average. And that really, especially with this kind of mapping, shows all the detail with all the counties, whether they're close to the average or the goal. Are they meeting the goal? Are they just above it or just below it? And then when you see those extreme values in the bright red and blue colors. So that's counts and amounts by color. What I like to do is add two fields. So one is the percent field, which is the color, and let's find another field that shows the count of people who drive alone to work. So now we're using the color and size drawing style. Let me go back in and change those settings for the color. We'll use the above and below. And best for dark backgrounds. Flip this ramp, and let's remove the background outline of the counties. And now let's go into the size component. And now we see greater variation as we drag this top slider down. So we notice here that on the West Coast, a lot of people, or a lower percentage of people, are driving alone to work. And then on the East Coast, you see a higher percentage. However, this changes in the Northeast around New York and Boston and DC. So we're learning a lot by exploring the data set with color, size, and color and size. So let's take a look at some other fields. Let's add a few of them here. Workers who commuted by walking. Actually, let's do this on the tracked field and zoom into a certain area. So now we can explore this data set at the tracked level and see greater detail. All right, so the tracked layer is activated, and let's go back into the fields and search for that walking, workers who commuted by walking, and compare that to workers who biked to work. And it's going to recommend color and size. If I added 3, it would have recommended predominance. But I'm going to show you what predominance looks like. With this one, it's kind of like a voting map. Who won the election, this person or this person, and by how much. So with predominance with this particular layer, we see closer to downtown, more people are going to bike, and outside, you see more people walking if you're comparing just those two. This doesn't include driving or taking the bus. And predominant category and size is something I recommend that people use. And this is this whole layer is for the whole nation. So let's make this look nicer for Portland by, again, bringing down that top slider. Another thing you can do with these two variables is use the dot density drawing style. So this style is nice because it really personalizes your data. We created a map recently on the homeless population in LA, and we had a polygon fill choropleth map, and we then compared it to the dot density map, and one dot on the map represented one homeless person on the street. So that just really makes the map a lot more personal. And we could change the dot value. I would recommend saying one dot represents one person in this case, and when you type that in, it automatically adds it to the legend. And there's a blend overlapping colors option that shows where the two values are pretty similar in that area. So I like this color scheme. So I would be done with this dot density map. However, I'm interested in exploring the layer a little bit more. So we have walking, biking, let's do public transportation. And so as I keep adding the fields, the map updates. If you have a lot of fields selected, I wouldn't recommend dot density per se. I think predominant category personally is easier to visualize when you add a bunch of fields. And again, I would choose predominant category and size for this one. And let's also add people who drove alone. Now, as I'm adding these fields, I'm exploring the distribution of the data. So let me turn this back to the polygon so you can see it. Most people in most tracks will drive alone to work. So now I'm learning, okay, well, that's not so great of a story. Let me remove that. And now we get greater variation. Most of the people downtown are walking. On the east side, they're taking public transportation, maybe the bus. And in yellow, they're biking. And if you keep working on the map, for example, using predominant category and size, you can change the symbols to any custom symbol that you want. So let me go to the Living Atlas, and I'll show you a map that I created from this data set. Search commute. You can find lots of layers and maps in the Living Atlas that will help you with your work. So this shows the most popular commute alternative to driving, and we see carpooling in red, walking in green, taking the bus in blue, and when we zoom in, we see the option to customize these predominant category and size symbols. So these are the symbols that I created on my own and added them, or replaced the circle symbols with these. So it makes the map easier to understand. You don't have to decipher the legend. You can look just on the map and it's understandable, informative at a glance, as we said earlier. So what I just showed was how to add and map one layer or one field, two fields, multiple fields using color and size, predominance, and dot density. You really have to think about your audience and what you're really trying to show, and that will help you determine what drawing style to use.
Okay, let's do another example here. I've got a map here showing what we call a relationship style. This map shows the relationship between two attributes in our data set that we're interested in. This is census tract information, again, from the American Community Survey, and also Esri's own demographic data provides daytime population density. In other words, when people commute into Los Angeles every day, where do they go? And this map is showing you areas in purple, according to this legend, areas that have a high number of working seniors, such as here in Santa Monica. The place I just clicked on has 401 working seniors, age 65 plus, and that's 32, or actually it's 70 plus. I got to fix the pop-up. which is 32% of that age group, and the national average is 13%. So this is a high number of working seniors, and there's 37,000 people per square mile, and anything over 1,600 persons per square mile is considered urban. So on these two dimensions, this particular census tract is high on both. And so you can kind of see an interesting pattern in the Los Angeles area where there's a strong Santa Monica corridor, there's some downtown activity. How do we get to this map? Why would we want to do it? So I'm going to show you a little trick we all use. When we see your web maps out there, one of the first things we do, if we want to experiment and play around with your layers, we'll just make a copy of the layer. And this is one of the little hidden features that's out there. It's very nice. So I've made a copy of the layer. Now that's mine, and I can do what I want with it. So what I'm going to do, I'm kind of going to work backwards. I'm going to take things out of this map and see where it goes. And what I love about smart mapping is it kind of helps you kind of just start to focus on, well, what if I just map these two attributes? I could kind of try any of these mapping styles. I think Jen was working with color and size earlier, and I could, use color to map the percent of population who worked age 70 and over recently, and then also map the daytime population using size. But what I want to do is go a little further back. What we could do, we could just map the percent of population age 70 and above who have recently worked. And we'd kind of get this sense of pattern in Los Angeles and then in outlying areas. And then we could work within that map to kind of adjust things so that anything below this average of 13% kind of gets rewarded with a small size on the map. And I can control how small. If I want, I'll go all the way down to, just barely visible. And notice how the map is starting to really emphasize only those areas that have a high percent. Well, how high? This map is saying if you have a value of 100% of the population age 70 or over worked in the past 12 months, we will reward you with a 50-point symbol size. And I think we can go up to 120, Jen? Mm-hmm. And at a certain point, it's like, oh, is this map actually communicating? Or do I need to back this down? Like I usually go with values of about 80. And then I work with this. So you can see how the map is swelling and becoming less and less useful. This is happening, by the way, no matter what mapping software you use. It's just in this particular interface, we make it a little easier for you to kind of experiment with values of significance. So let's say we want to tell a story about, these are the areas where 50% of the seniors are working, right? And even if I drop the point size down to 40 points or pixels, okay, for argument's sake, this map is telling a little bit of story. I just learned that you can find a lot of working seniors in the northern part of Los Angeles County. And I can make that map. Now, I could also, let's do this trick again. Let's copy that layer. And this time, I'm just going to map the other subject, right? I'm going to go in here, and I'm going to take that thing off. I'm going to flip these attributes so I can delete the percent population. And now I'm just mapping this Esri figure daytime population density. So bearing in mind that a value of 1,600 is what the common 1,600 persons per square mile is what people consider urban. I'm going to drop that size down to kind of start out. I'm cleaning my palette right here. I'm cleansing my palette. I'm saying, let's clear out all this data at the bottom end of the spectrum. But right now, this is an outlier-driven map. There's one census tract somewhere in the United States that has 417,000 people per square mile. I guess it's probably a very big building. So let's start to drag this down until we start to see some signal in the map, right? Oh, I lost the signal. Why? Because I went too far. I'd rather do this quickly with a slider bar than any other method. So it's one of the reasons I love working in online. I can make mistakes quickly and iterate until I get the map looking right at the scale I expect people to use it. I'm not trying to solve the problem of making this map look perfect at all 20 levels of detail available in a web map. So I'm just trying to work with something reasonable here. And for argument's sake, let's say this is the scale at which I want this map to operate. And nobody knows what 200,000 persons per square mile feels like. So we want to communicate that visually. Again, increasing the size until I feel like, okay, I'm making my point. Can you start to see downtown in Los Angeles yet? And then did you know that parts of West Los Angeles seem to be kind of creeping up on that density as we go along, right? And even though there's no circles this big in this map, I'm having the effect I desired. So, one way we do things is we show people, this first map about about seniors, to make things clear, I would rename things. So, wow, that's exciting. I would rename things. I don't know what I hit there, Jen, but joys of working from home, right? And then, so we call this working seniors to get clear. And then I would call this map daytime population density. Yep. Okay, cool. So, and then, oh boy, let's put the two maps together, right? And then you can see what's going on. Well, no, I can't. And that's the reason we invent these other map styles where you can go in and merely point at each of those attributes and then add a size component showing what is the actual total daytime population. And what that map looks like, in terms of the options, I've got various colors I can work with. So if I want to work with greens and purples, I can do so. Or if I want to shift to different color palettes, it's very easy to kind of try out what seems to grab the attention, whether you're looking for a story about where you want to emphasize its high concentration of both working seniors and high population density. Maybe you put that in a particular color that you're interested in. And then what I really enjoy is you can go in and edit these labels. I think normally they say high and high, so we don't want to do that. Here we go. And we would just label this by hand until we get what we want. That way it's kind of clear on this legend what the map is actually trying to communicate. What I enjoy about that is there are tons of maps. You can make one map at a time per attribute, but some of the more interesting maps that are in existence out there kind of lie at the intersection between two or more attributes. And that's one of the things we wanted to make you aware of when you're thinking about making maps. Don't just accept the columns of data as given to you. You know what I mean by that? That's, when you look at the data in a columnar form, here's a field called, I think it's way out here, percent of population, where'd it go? Yeah, there's our daytime population density. Don't just think, oh, I have a column of data and I have some statistics about the data. I guess I have one map that's possible from that one column of data. Think of it as if you have two attributes, we have found you can make probably 14 to 20 maps from those two attributes, just all using all these different map styles. So I'll pause there so we can go on to the next example.
Thanks, Jim. Yeah, a lot of us work with Living Atlas layers because they're ready to use, but sometimes we need to find layers from our city's open data site or the hub site, and most of the time they aren't ready to use or not as ready to use. So here's an example of something I just found last updated yesterday. It's a trails layer in Chesterfield County, Virginia, and I'll open this layer up in a web map. It's opening it up in the 3x web map, but if I wanted to, I could open it up in the new map viewer beta as well. So let's zoom into somewhere interesting. Let's go to this park here, Rockwood Park, and we see the trail type. So this is the symbology set with the layer. We have asphalt, concrete, constructed gravel, etc. Now the colors aren't really working with this base map, so let's find another natural looking base map since we are talking trails. This is the modern antique map, and I think that looks pretty good, but let's make this map a little better. I'll add another attribute that shows the width in feet of each trail. So the color of the layer is the trail type, what the material the trail is made of, and the size of the line is the width in feet. Now, if I wanted to show the width in, say, meters, I can go on this drop down, and I notice that we don't have the width in meters. What I could do is I could call or email or try to find the owner of the person who made the trails layer, or I could create a new arcade expression, and that's a lot more time efficient. So here we're opening up the arcade expression builder, and we can write a very simple script. Think of this as something you would do in Excel, maybe adding a bunch of fields together or multiplying or dividing, or we can even make more complicated scripts using if-else statements or when statements. So I'll show a very simple script or expression first. So we have our width in feet, and we multiply it by, 3048? Something like that. Let's say that's the conversion. And we give it a name, so width in meters. And this name that's shown as the title of this expression will appear here in the legend. And then all the numbers are already converted for you. So that's really time-saving. Now let's look at the types and size. So the types are the cover of the trail, and the size is the width. And do some quick little changes. Here's the average width, we'll say around 1, and give this a rounded number of 4. And now we see greater variation in the layer, and I'll decrease the maximum width size to around 12. And then we can change the colors of each category. There's a lot of color ramps to choose from, whether it's a bright color ramp or maybe a more neutral nature feeling ramp, such as this one. So that's what we could do with Arcade is, it gives you that ability to change the data on the fly, even if you don't own the layer. So it's really a handy tool. All right, so let's view a more advanced arcade expression that you can write to view change over time. This is another popular layer in the Living Atlas called Popular Demographics in the United States. And I'll open this one in the new Map Viewer Beta so you can see arcade expressions in there. It's going to look the same. So whether you're working in the classic Map Viewer or the new beta, you'll have a similar experience. All right, so first I'm going to change the base map. You're seeing a common trend here. First step, change the base map. We'll look at the human geography light gray base map. And let's take a look at the styles panel and view the attributes in this particular layer. We have 2010 population, and then we also have 2018 population. But what we don't have in this data set is the change over time. So that's where arcade expressions comes into play. So before we were showing adding a field here, now we can add an expression very easily in the styles panel. And here we see the expression builder. I will give it a name. So change in population from 2010 to 2018. And the first step is to create a variable. So the first one I'm looking for is 2010 population. And the variable name will be called pop10. And we'll create a second variable for population in 2018. And that's here. All right, so I'll add a when statement. There's lots of functions you can use: absolute value, area, buffers, difference. There's text functions, numeric functions, date functions, even spatial functions like the buffer. But for now, let's use a when statement. And to learn more about it, you click on this little I, And we see that it evaluates a series of conditional expressions until one evaluates to true. So when Pop 2018 population is greater than 2010, that means there was an increase in population for that county over time. However, when the population in 2018 is less than 2010, there was a decrease. And for all other conditions, for all other expressions, we will return no change. So we can test the result, and we can add dummy values. So say right now there is an increase, but say we put this dummy value to 0 and test it again, now there's a decrease. So that's a really fun way to make sure your expression is doing what you expect. So here, what we've done with expressions is converted numeric attributes to a string, increase, decrease, or no change. And we see in this map increase in population in red and decrease in blue. But let's implement that color and size theory that we've been talking about, this method that we like to use, by adding another expression that shows the difference between both of those years. Now, before I do this, I want to go back into this original expression we wrote and copy and paste it in. There will be an existing tab in future releases of Map Viewer Beta that will allow you to simply click on expressions you've already written. So I have my two variables. You can comment out a line if you want, or simply delete it. And I'm going to use the absolute value function because I don't want a negative value to determine the size of my symbol. So absolute value of those 2 years. And of course you want to name your expression or else it's going to say new expression in the legend. And let's make this map a little more meaningful by bringing down the size of the top value and removing the background, county boundaries. And we can even change the custom size so we can give that lower value a bigger symbol. So as we can see, most counties are experiencing an increase in population, and then the rural counties, some of them are experiencing a decrease in population. Of course, we'd want to play with this map a little bit more to get it just right, but that's how you can use arcade expressions to create new categories and strings based on numeric fields. All right, so the last example I want to show related to arcade expressions deals with the pop-up and a spatial attribute that is created with the expression. So here we see where the International Space Station is currently, what country the International Space Station is currently flying over. And we have the world cities that are symbolized by their population. You can view this in the legend here. And the space station. This is a live feed layer that's constantly being updated as the space station flies over us. Now, if we click on the station, we're using arcade expressions in the pop-up. Let me dock this over here to view the country that it's currently flying over, and it sums up how many people can actually see the station. I know Jim did a lot of research on the angles and the horizon, and we implemented that into the expression to calculate that number. So it's just an estimate. So here is the expression that drives the pop-up. So what it's showing is the country and the number of people that could potentially see the space station. So here in the pop-up, we can manage expressions. And there are two expressions. One is where is it flying over, and the other one is the sum of people. So let's look at the first one. This takes advantage of something we call feature sets. And the nice thing about feature sets is it lets one layer talk to other layers and gather information from other layers in the map, or even if they're not in the map, you can call them by their ID. So here we call the country and the water body layer using the feature set by name function. And then we find which country or which water body the point International Space Station is intersecting with. And then if it's intersecting with the country, we return the country name in that pop-up. And if it's intersecting with a water body, we return the water body name. And the second expression we use determines the amount of people who can potentially see the space station. So we're using feature sets to make a phone call to the world cities layer that's in the map. And this is a buffer geodetic function that creates a 1,000-kilometer buffer. So you can change this value or change it to a different unit. And then what it does is it finds all the cities that fall within that 1,000-kilometer buffer around the space station, and it looks at the population field of those cities that intersect in that buffer, and it adds them all up. So pretty cool, very advanced example, but I wanted to show that to you to give you an idea of, what you can do. Your creativity and your imagination is your only limit with arcade expressions.
What I really appreciate about this is, traditionally, I think a mapping-focused person would simply overlay some population density or, these cities sized by population and just call it a day, right? It's obvious that the space station is currently flying over some unpopulated area or some populated area. If it flies over Paris, London, New York, Mumbai, it's going to be seen by a lot of people. But I love that we now can use those same layers to actually generate a number and an estimate of how many people are currently, if it's nighttime especially, looking up and seeing this. I tracked the space station on one of those little apps that tells you when it's coming over your house soon. And we always just run outside with the kids and go check it out. So we're one of, 20 million people in the Los Angeles area who look up over and see this thing when it flies over. It's amazing. Okay, great. Let's do one more example. This time we're featuring this web application that our colleague Christian Akenis built for the 2020 Dev Summit Plenary. If you go on YouTube, you can actually watch him demonstrate this live. This is the blog he wrote to kind of give you the backdrop around it. This app loads a ton of data as points. Picture around Antarctica there, right about here. Every single dot on this map is a point, and there are scores, if not hundreds of points going from the ocean's surface down into its depths, where there are modeled estimates of salinity, temperature, and other characteristics. So the idea here, as you can see from this animation, was to allow someone to explore that data intuitively and kind of start to learn something about, in this case, temperature. Some of you might expect that temperature is highest at the ocean's surface, and then it changes as you go further and further down into the ocean. But at what point does it reach, 10 degrees Celsius? Well, it's at about 500 meters below the surface, according to this chart. So how can you learn that, and how do the visuals help? Notice that the projection is not Web Mercator. It's a web map, but this is something called the Spillhouse projection, which was released just a few days or weeks before this demonstration was created. And then it allows you to his application allows you to explore the data by drawing, a line across things, and it'll summarize that profile of temperature or salinity within a certain distance of that line, which is kind of cool. So it's very much about exploratory. But the reason I wanted to show it was to take a look at the code behind the scenes to kind of talk about, well, how did Christian come up with these colors? And how did he come up with at what temperature or salinity this is? At what salinity level would we use one color versus another color, right? And a lot of this comes down to, in my observation, what I wanted to share with you about this, sometimes you have people who write code really well. Maybe they're not comfortable with color. Christian is the exception, but he also is smart enough to go and seek counsel, in this case from our colleague Keith Van Graffelen, about the topic, the subject matter, the salinity, what is salinity, and what are meaningful measures, and what kind of colors would help bring that to life. So it's not an accident that these are really strong colors, and you can almost see the convergence zone, or whatever the right term is, for where, in this case, temperature changes relatively rapidly over a short distance, right? I guess this is off the southern tip of Africa near Madagascar, and at this depth, right at the surface, it looks like the temperature is extremely warm near the coast, and we kind of expect that, but look at the mixing that occurs just off the coast, a certain distance from it. And so how do we accentuate that? And what I enjoy about my job, I don't know about you, Jennifer, but I really enjoy that moment in a project where the data is here, it's working, and people have confidence in it. And someone smart like Christian has gone in and created the application and provided these colors, these what we call stops. At what point is something this particular color? Well, up until the point it reaches 33 degrees, and then we're going to start transferring it, or salinity. We're going to start transitioning that color to this next color in the sequence, which looks like it's kind of a black color, right? This middle color is this, and then the blue color, or I guess this is the red color, it's a higher salinity, etc. So how do we kind of experience that? I think our favorite part of the project is once people have the structure of the data in place and the structure of the code in place, we then can walk in and start talking about, well, how many stops do you need? Usually 3 is a good number to transition from one color to another, but maybe on temperature, you can see here the team chose to use 5 stops to give them a little more fine-grained control. The point is, in smart mapping, all that is pretty much burned into the user experience in the map viewer or beta map viewer. You get a certain number of stops according to what was agreed upon when people designed the user experience. But in code, you can have as many stops as you want. You can have as many colors that you want. So the freedom you enjoy, I think, as a developer is greater. And if you happen to be someone comfortable with color and other characteristics of cartography, then I think you're going to have a great time in here. The point is, we always start with, hey, let's get that layer into a map viewer so we can kind of see what we can do out of the box, so to speak. And then if that's not adequate, well, at least we have that web map to start from, and we can point to it. We'll often send a web map over to a developer and say, here's kind of what I was thinking, but I think I need more stops, or I need more color, or I need a different size. We mentioned earlier in this demo, 120 points is the maximum size. Maybe we want to go to 130 for some reason. So that's the reason for kind of showing this example.
So let's go back to our story map and do some Q&A.
Cool. I think you and I have to take the role of the questioners since we don't have a live audience. Yeah, I think a typical question people ask is, in smart mapping, it's got all these suggested color ramps and defaults. Can you kind of verbally describe, as opposed to pantomime, how these decisions are made about what color ramps to put in and how they are associated with a base map?
Mm-hmm. Yeah, there's a lot. I could go on for days about this answer, but I'll show you the code. We have the types. We have above and below and high to low. And so this is what it looks like in the code itself. And it's using this extension called color highlights. So if you put in a hex value, it automatically colors it in the code to that hex value, which is really, really helpful when we're designing these color ramps. We have designers who will come up with the color ramp, and then we have cartographers and geographers who test it out on the map with real data to see if it's working. And then we have people who will tag each of the color ramps. Is it best for dark base maps, or is it best for light base maps? As you saw in the categories, these tags drive what is shown in each category. Here it's a sequential, and it is colorblind friendly. Now, let me find a nice above and below ramp. Let's see. Oh, here we go. Here's a diverging. And let's use the color oracle on here. This simulates the most common colorblind, what a colorblind person would see with deuteranopia. So we can see that there is a distinction between the top values and the bottom values. So this is indeed colorblind friendly. Now, if it's red and green, that's usually the most problematic. What the designers do with that is add a little bit of a blue tint to the green to solve that issue. Now, if you are interested in the story, we have an Esri color ramps guide, and this is what developers can use to find the best ramps for their data, for their maps and apps. And it's using that code that I just showed you. And there's the different schemes, the different colors, diverging, centered on, and then we can choose the number of colors, or we can filter by hex value even. And all you have to do is copy the hex values and put them into your code. That's a really great question.
So this is great. I mean, these are not just things that are, kind of so-called stuck in an application like the map viewer. These are available cross-platform. They're documented. There's blogs that people could just grab this and use.
Mm-hmm. It's right there for you to use.
That's a really great resource.
Yeah. I have a question for you, Jim.
Uh-oh.
So something I hear a lot actually from developers is, our graphics team is picking the colors. What can I do? I'm not a cartographer or a designer. What would you say to them?
Yeah, it's cool. I mean, a lot of times people in the graphics team or the creative group or the web development, the website, people who know color, they know it from previous experiences, right? And they may or may not know it from a mapping experience. They may not have been through some of our presentations about the need to de-emphasize on the map things that are unimportant and bring up those things that are important through color, size, use of transparency, and all that. So my advice is usually, hey, go with whatever colors they want to use, try to put it on the map and discuss it, show it. And then our philosophy, we talk about this on the team all the time, give people exactly what they asked for so that they can kind of check that off their mental checklist of, hey, I asked you to use our official company colors for this map. And you check that box off, hey, I delivered it as expected and I've made it the best I could be. And then we always will try to deliver a map we think is a little bit better. And we kind of, approach it from the perspective of, here's why this is working a little bit stronger. We chose a different base map or all the things we talked about in this lesson. Here was our reasoning. And it's the reason we approach it that way is you cannot expect somebody who's never made a map before to understand everything there is about how to make a great map. Mm-hmm. You can only, meet them where you're at, meet them where they're at, and try to do the best job you can given what the purpose of their map is. And that's the secret sauce we try to bring to the table. If someone cannot state what the purpose of the map is, the chances that you're going to be able to deliver it as a developer is greatly reduced. So it's all about how do you kind of drive that conversation forward. And iteration is your friend, right? Mm-hmm. These are, in our case, a lot of times we're doing web maps. So the cost of iterating is not very high. You can make a setting change. You can change sizes and just kind of explore, hey, look, when I do it this way, here's what's positive about that, but look how it negatively impacts this other thing. Which of those two things is more important to you? What is the purpose of this map? And if you kind of hurt the conversation or drive the conversation in that direction, usually that leads to the realization, oh, we don't have to build one Uber map, one super map that accomplishes all things. We can have several maps. This map emphasizes high expenditures. This map emphasizes growing expenditures. This map emphasizes low expenditures. And so there's a purpose for each map. That's my long-winded answer.
That's a great long-winded answer. And I agree. It's better to show what they asked for and then what you think is best. I find that giving 2 options is a lot more helpful than maybe 5 options or 10 options. Keep it down to 2 or 3.
Yeah, that's a good approach. And you and I talk about this sometimes a lot. Sometimes you're not going to You're not going to quote unquote win. And sometimes losing a discussion, you know, you have a recommendation, they don't want to do it for whatever reason. They prefer this red, not that red. Sometimes it's better for folks to learn the lessons they need to learn, right? In their own time, in their own way. You're still here down the road, ready to help advise. I have a question. Let's take one more. We got time for one more?
Sure, one more.
All right. This is a classic. So Jennifer, this happened to me this week. I have 1.2 million physician offices to draw on this map. What should I do?
That happens to me all the time. What should you do? Maybe don't do it. I would recommend maybe binning it into hex bins or a meaningful geography such as, you know, congressional districts or census tracts or zip codes, depending on what your story is and who your audience is. Doing so gives you a greater visualization and pattern than putting all 1.2 million features on the map. Now, other things you could do, you could cluster it. So there's a clustering button that automatically clusters all your points, and that's very helpful. You can make a heat map out of it. If you must show 1.2 million features in Pro or Desktop, I would add an attribute or spatial index, and then when you publish it to online, make sure to change that cache to 1 hour. That's in the Settings tab, and that should help speed things up a bit. But, you know, in the end, try not to draw 1.2 million features on your map. Not useful.
It's kind of a cry for help, isn't it?
Yeah.
Like, I have all these features, and there's so many, you can't actually see them, but I'm going to draw them anyway, knowing you can't even see them all. Right? There's something about that that's sort of attractive to me as a problem to solve for people. And the way we choose to discuss it is to say, hey, what if you didn't draw a 1.2 million? What if you asked yourself, what do you really want to learn from drawing this or from rendering it? What are these features? What do they mean? What are they good for? And just, again, taking people down that conversation path.
Right, take it to the next step. All right, well, speaking of next steps, here are some resources for you to check out. You will have access to this story. You can view blogs on smart mapping and Arcade, view the Living Atlas for lots and lots of layers that you can start from, and the Color Ramps guide that should help you with choosing your colors. And we'd like to say thanks and happy smart mapping to you. I'm Jennifer Bell.
Yeah, and Jim Harris, thanks for coming along this journey with us. We hope you will go into the map viewer, either version, make some maps, or go into Living Atlas or an ArcGIS Online, find web maps that seem to cover what you want to do, and then start to modify them. Hit Save As, make it your own, and then take that user ID, or sorry, that item ID, or that REST endpoint, put that into your apps directly so that you kind of author in smart mapping and then consume it in your application directly. I think that's a great pattern to work from. So hopefully this has been useful to you, and thanks for watching.